subscribe to my channel and press bell icon for latest updates.
Hi, welcome to Learning Monkey. I am Vikram. In this class we will try to understand what is meant by a binary tree and tree traversals. How to traverse a tree, that we will try to understand in this class. So what is meant by binary tree? What is meant by binary tree? Every tree, any tree in which every node is having at most two children is called as binary tree. So what it states is, if you take any tree, if every node in the tree is having at most two children, then that tree is called as binary tree. So what is meant by at most two children? So what is meant by at most two children means we may have no children. If you take a node, it may not have any children, it may have one children, or it may have two children. So it should not have more than two children. It should not have more than two children. So that is what we call it as at most two children. We will try to understand that definition by using these three examples. So let you guess, please let's guess which one is going to be a binary tree and which one is not a binary tree. Please pause this video for a while. Based upon the definition that we have given, try to guess which one is going to be a binary tree and which one is not going to be a binary tree. So is it a binary tree? Yes, it is a binary tree. How can we say that? Because if you take every node in the tree, it should have at most two children. At most two children means this is a node and it is having two children. It is having two children, at most it is satisfied. If you take this node, it is having two children, it is at most. If you take this node, it is also having at most two children. If you take this node, is it having two children? No, the rule is at most. It is not exactly two children. So what the rule states is, a binary tree is a tree in which every node in the tree should have or will have at most two children. Okay, so at most means it may be no children, it may be one child, or it may be two children. So if any of these cases is there, means then it is going to satisfy the property of the binary tree. So this is not having any children, so it is a property of a binary tree. It is also a node of a binary tree, and all these nodes are the satisfying all the properties of the binary tree. It is having at most, every node is having at most two children. So in this case, is it a binary tree? Yes, it is a binary tree. The only one which is having here it is having two children, this is also having two children, this is having only one child. The definition states that at most two children, which means it should not cross two children. It may be equal to two children, it may be less than one children, it may be less than two children, it may be one child, or zero childs is also satisfied for the based upon the condition of the binary tree. So is it a binary tree? No, it is not a binary tree. Where it is failing the property of a binary tree? It is failing at the node B. How many children does the B is having? B is having three children. It is not the case of the binary tree. Binary tree should have at most two children. It is having more than two children, so that is the reason why this is not a binary tree, and these two trees are binary trees. Okay, so this is about a binary tree. Now we will try to understand tree traversal. What is meant by traversal? What is meant by traversal? Traversal means passing through every node in the tree is called as traversal. If you are given with a binary tree or any tree, if passing through every node in the tree is called as tree traversal. Okay, so now here for example, we will try to understand it with a very simple example. So this is a binary tree. This is a binary tree. What does a traversal means is passing through every node. So once you start here, if you process this node, if you are able to process through, if you are able to pass through every node in the tree, then it is called as traversal. So for example, if you start with root node, printing the root node, processing means just printing the value which is there in that node is called as processing. So next, if you print B, okay, then if you print C, if you go through C, so then it is called as processing. This is what we call it as traversal. We are able to pass through every node in the tree. Okay, so how this traversal can be done is, this traversal can be done in three different ways. What are those ways is called as, what are those ways in which we can traverse through the binary tree is, it is pre-order traversal, next one is in-order traversal, and next one is post-order traversal. So we can use any of these mechanisms for the traversal. We may use a pre-order traversal mechanism, we may use a in-order traversal mechanism, or we may use post-order traversal mechanism for the traversal of a tree. So what is the difference? What is the difference between pre-order, in-order and post-order traversals? What is the difference is, if we, so it is totally based upon the accessing of the root node. Pre-order means if the access of if the processing of the left and the right child, if the processing of the root node is done prior to the processing of left and right child, then that kind of processing is called as pre-order traversal. That kind of traversal is called as pre-order traversal. What does it mean? If the processing of the root node is done prior to the processing of left and right child node, then that kind of traversal is called as pre-order traversal, which means roots processing is done first, then the left child's processing, and then the right child's processing is done. If the processing is done in this way, it is called as pre-order traversal. What is meant by in-order traversal? If the left node's processing is done first, then the root node's processing, and then the right node's processing in a tree or in any subtree of a tree, if this kind of processing is done, means it is called as in-order traversal. So what does it mean is, left node is processed first, root node is processed next, and right node is processed at the last. If that kind of processing is called as in-order traversal. What is meant by post-order? Post-order means the roots processing is done after the processing of left and right child. Then that kind of traversal is called as post-order traversal. So left child, right child processed, and after that, if the root node is processed, then that is called as post-order traversal. Okay, so these are the three different kinds of traversals. Based upon these traversals, which element is get processed in which order, that we will try to understand. So every traversal is going to have its own order. Okay, so now what they are saying is, if the root node is processed first, so this is the root node, if you process it first, it is this is called as pre-order traversal. After the root node, if we process the left node, and after the left node, if we process we have to process the right node. So this is what we call it as pre-order traversal. In the in-order traversal, what we have to process first is, we have to process the left node first, and we have to process the root node next, and we have to process the right node next. If the process is done in this way, it is called as in-order traversal. And post-order traversal, left node is processed first, right node is processed next, and root node is processed at the last. So this is what we call it as post-order traversal. So these are the three different kinds of traversals that can be used in our implementations. In order to traverse through the tree, we can use any of these implementations. So this is the program for pre-order traversal. In this program, so what is the structure of the node in a tree? What is the structure? So as we have discussed in our linked list, the structure of a node. In that way, what are the elements that are there in the structure of a tree node? It is struct node, star left. So we are going to go with the left node. So this is going to store the address of a node which is of type struct, and next one is int val, int or char, it can be of any type. So as we are going with alphabets, go with char. Struct node star right. Right is a pointer which is going to store the address of a node which is of type struct. So how can we visualize the node? So this a node in the tree can be visualized in this way. This is going to have the value, this is going to have the left node's address, and this is going to have right node's address. So for example, if you take this part A, B, C, so so consider this tree, how can we visualize on the memory? That is very important to understand. So this is our first node here, it is going to have the value, for example, if the head node, root node is having the address 100, it is just for our visualization, it is given, we are taking it as 100. So how the node will be is, so the address of the left child's node is in the left part, and this is the value of the root node, and here we have the right node's address. So the right node's address means in this way. Here see. So does this node have left and right childs? So from this diagram, does this node have a left and right child? No, it is not having left and right child. So what we have to do is we have to put null. Okay, and this is going to be 300. Are you able to get it? So that discussion about this structure and all that was already done in the linked list. Okay, that is the reason why we said that linked list is the key data structure that needs to be understood very well. Okay, so now coming to the traversals. These are the three different, okay, this is the program for pre-order traversal. How this pre-order traversal works is initially the value of n, the value of head is transferred, and it is stored in n. So it is pointing, n is pointing to the head node, and is n not equal to null? If n not equal to null, is n equal to null? No, n is not equal to null. If n is not equal to null, we have to print n dot value, where the n is pointing to 100. 100 dot value. What is the value stored in 100th location? The value is a. So we are going to print a, and after that we are going to execute this line of code. This line of code is n dot next. N dot next means 200. N dot next is 200. So the new value of n is 200 in this function call. Now what happens is, what we are going to do is n not equal to null, 200 not equal to null. Yes, 200 is not equal to null. So in that case we are going to print n dot value. What will get printed? N dot value means now the value of n is 200, n dot value is b. Okay, again we are going to call pre of n dot left. Pre of n dot left means n is pointing to 200, n dot left is null. So n dot left means n will get stored with null. Okay, now is n not equal to null? No, it is not. N is equal to null. If n is equal to null, we are going to come out of this if condition. We are going to come out of this if condition, and we are going to go to the where we have stopped in our previous example. So in the previous function call, we have done this and this one is done. We came here and next we have to go to this n of right. Okay, so this is the way in which recursion works. I am not again explaining about the recursion. So this function call is made, n of right is null, n of right is null. So we are going to again come out of this entire function call, and after that n of right, where we have stopped at 100, n of right is 300. We are going to go to that side and we are going to print we are going to go to this right side and we are going to print this C, and after that we are going to come out of this entire function call. So the output is going to be A, B, C. Okay, so this is the way in which a pre-order function call, this is the program for pre-order function call. In the same way, can you guess the program for, can you write the algorithm for in-order traversal? So the magic lies in between these three lines of code. So what, in order to write the program algorithm for in-order traversal, what we have to do is this printf has to be here, and this line of code has to be on the top. We have to go to the leftmost node, and the value in the leftmost nodes has to be printed first, and after that the root node has to be printed, and after that right nodes will get printed. So that is the way in which an in-order traversal will work. Similarly, for the post-order traversal, this printf should be at the last and these two should be on the top. So we have to print the last, print at the last, this printf function has to be kept in the last, and these two are to be on the top of the printf statement. So that is the program for post-order traversal. Okay. Now we will try to understand a shortcut for the pre-order, in-order and post-order traversal by using that example. What is the answer? Now we will try to understand what is the answer for pre-order traversal, the order for the pre-order traversal, in-order traversal and post-order traversal. Using a shortcut, we will try to understand the pre-order, post-order and in-order traversals. So what is the logic behind the pre-order, post-order and in-order traversal is whenever we will try to understand, we will try to process the node based upon the visits to the node. So based upon the way in which we visit the node, we are going to process that node. So what is the logic behind pre-order, in-order and post-order is the way in which we visit the node, based upon that we are going to process that node. So what is that means is, the best way is just draw the dummy nodes for every leaf node. Draw the dummy nodes for every leaf node. So we are trying to understand the shortcut method for pre-order, in-order and traversal, post-order traversal. So what is the technique is, draw the dummy nodes for every leaf node in the tree, every leaf node in the tree, and as we know, the processing technique is it is from top down and left right approach. Whenever we visit the node for the first time in the process of traversing top down and left right approach, this is the way in which the recursion work. So in that way, whenever we visit the node for the first time and we print it, if we are printing the value in the node whenever we visit the node for the first time, then that is called as pre-order traversal. If we print the node value in the node whenever we visit the node for the second time, it is called as in-order traversal. In the same way, if we print the value in the node whenever we visit the node for the third time, it is called as post-order traversal. That results in post-order traversal of a tree. Okay, so the recursive technique is left, top down, left right. So this is the way in which a recursive function will work for any function call. Based upon that, we are going to draw the traversals. We are going to find the traversals of a tree. Okay, so this is the way in which the recursion will work. So the technique is whenever we visit the node for the first time. So this is our first visit of this node. So if we print the elements, in such a way, with our first time visit, whenever we visit the node for the first time, if we print that first time visit value, it is called as pre-order. So this is going to be the first time visit, and again when we are going to visit the node A, so after all these traversal, we are going to visit the value A here. So second time we are going to visit A here, and third time, after the traversal of all these nodes, we are going to visit A for the third time. Whenever we print the visit of the node for the first time, it gives the order of pre-order traversal. Whenever we print the second time visit of the nodes, it gives the in-order traversal. Third time visit is going to give the post-order traversal. So first, second, third, in the same way, first, second, third, similarly for this first time, second time, third time, first time, first time, second time, third time. Okay, so now we will try to extract the pre-order traversal, post-order traversal and in-order traversal for this tree. So we start from here at the first time visit. Start from here, left to right, that is common for any tree. So we are going to start from here. Whenever we visit it for the first time, it has to be printed. So next we have visited it for the first time, it has to be printed. Now we are visiting it for the first time, it has to be printed. So this should not be printed, because in order to get the pre-order traversal, we have to print whenever we visit the node for the first time. So this should not be printed. Third time visiting, second time visiting, this is the first time visit. So this is the first time visit, just print it. This is our first time visit to H, so print it. Similarly, this is not going to be the first time visit. This is our first time visit to C, print it. First time visit to F. So first time visit to G. Next, first time visit to I, and first time visit to J. So remaining all are going to be second time and third time visits. So this is the way in which the things will get printed using pre-order traversal. Now we will try to print the in-order traversal. Whenever we visit the node for the second time, print the value. Whenever we visit the node for the second time, printing the value gives the in-order traversal. So start from here. First time visit, no need, we have to print only at the second time visit. First time visit, no need. First time visit, no need. So this is our second time visit. Whenever we visit the node for the second time, we have to print for in-order traversal. So that is the reason why leftmost node is getting printed first. Okay, so after this we have to go through this, and this is the second time visit, so B has to be printed. In the same way, this is our first time visit, this is our second time visit of H, so H has to be printed. After time, this is third time visit, and this is our second time visit of E, it has to be printed. In the same way, this is the second time visit of A, and after that second time visit is F, and after that C, after that I, and after that G, and after that J. So this is the in order traversal of a tree. What is the post order traversal? We have to print the element if we visit that element for the third time, then only we have to print. So first time, second time, and this is third time. So we have to print D here, and second time visit, after that first time visit, and this is second time visit for H, and this is the third time visit of H. So H has to be printed, and after that this is the second time visit to E, and third time visit to E, third time visit to B. Okay, D, H, E, B, and after that second, first time, second time, and this is the third time. So F has to be printed second time, first time, second time, and third time. So I has to be printed second time, first time, second time, third time. So G is third time, C is third time, and after that root node is third time. So this is the post order sequence. This is the sequence in which a post order traversal will get executed. So if you implement, we can implement the traversal of a tree can be done by using any of these three methods. If you implement your tree traversal by using pre-order method, we are going to print this way, where the elements will get printed in this way. If you use the in order traversal, this is the order in which the elements will get printed. So the traversal is done in this way. Okay, this is the order in which the traversal can be done, and this is the order for the post order traversal. So this is the technique. It helps a lot in answering the gate bits. So using this function, if you try to do it, it is going to take a lot amount of time. But if you practice this kind of this shortcut method on 2 to 3 different kinds of trees, it becomes very handy. You can write, you can do it very fast. So that is the reason why we have explained this shortcut method, and this helps a lot in our gate examinations. We are going to solve lots of problems on tree traversal and also in the tree examples, where we are going to understand the efficiency of this shortcut. Okay, so this is all about binary tree and tree traversal, basic tree traversal techniques. We are going to see in our next video more tree traversal methods that were asked in placements and also for the gate. So that we will try to understand in our next video. Hope you understood. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thanks for watching.